All right, you guys need to get out your periodic tables. Oh, I totally know what you're going through. That's why I like stay up till 3 o'clock in the morning, because I have to finish the book. But it's so good, yeah, you don't want to put it down. Justice. Okay, yesterday we talked about the protons, neutrons, and electrons. And just by looking at one element on the periodic table, you can tell lots and lots of different things about it, right? So we were able to draw the model of the atom, correct? Okay, why would we have to do a model of an atom? Dagny?
So we know what it looks like, so we can do that.
So we know what it looks like, so we can do that?
Yeah.
Okay. Why can't I just like look at it so I know what it is, what it looks like?
Because you got the math and stuff.
Because it has the math and stuff. Like how come I can't just say, oh yeah, look, there's the atom, I got it. I know what it looks like already because I can see it. Bam.
You gotta look at these, what's it called? The symbols. Things.
You have to look at the block thing. The elements.
The elements.
Okay. But why do I have to draw a model of it? Why can't I just look at it? Casey? It's easier to remember what it looks like. Okay. Have any of us ever seen an atom?
No.
Why?
Because they're so small.
A really tall building. Okay, so sometimes we have really tall buildings and they make smaller models of it so you can get a better idea of what it looks like. Okay? The world, exactly. Because we can't really see our world, right? We can't like, let me go back in space and, oh, there's our world, right? Okay, what do we do in order to see the world? What's the model of the world that we use? A globe. Okay, so when we have something really tiny like an atom, we have to make a bigger model of it. But when you have something ginormous like the world, we have to use a smaller model of it. Okay, so here's what we're going to do today. One kind of works. So you guys are going to be designing your own atom. Now, what made this one not as great as it could be? Dagny?
The electrons are bigger than the protons and neutrons.
Okay, electrons are bigger than the protons and neutrons. Well, what's wrong with that?
The electrons are 1/2000th of a AMU.
Okay, so the electrons are actually 1/2000th of an AMU. Which one of these particles is supposed to be 1 AMU? Maya? The proton. Can you even tell by looking at this which one is a proton?
No. I think the green.
Well, either the red or the green. We're not sure. The green maybe? Okay, why would you think the green, Leisha?
Because the purple looks a little bit, and the green looks a little bit, and the red is a lot.
Okay. What else?
Because there's more reds than there is greens. Because from the looks.
Okay, looks like there's more red than green.
Yeah, and then.
I guess we could sit there and count it. Well, this is supposed to be chlorine. There's supposed to be 17 protons and 18 neutrons.
So the red is the proton.
Because you counted them and there's 17 of them? Laura?
I think it's because usually there's more like neutrons than protons.
Okay, usually there's more neutrons than protons, right? There's usually the same amount or a little bit more. How do we figure out the neutrons again? Guys, remember? How do we do neutrons? Kaden. Who left? And who was your fourth? There was only 3 of you? Only 3. Okay, we'll move someone else because she switched classes, yeah. Okay. Okay, you're there. Okay. And I am so not putting you over there. Garrison, go with the girls. That just means you get to be the boss of someone else, right?
I don't like being boss.
Sure.
I love being the boss.
Yeah, we know. Okay, boss them around, figure it out. What are you going to do? Proton, neutron, electron. Proton, electron, guess your neutrons. Okay. I didn't give you an element yet. You just start making them.
Okay, let me just.
You might have to, yeah, see. Okay, what are you doing? What are you doing?
Protons. Neutrons.
Is it that stinky?
Oh no, he was doing that inside VO2.
Oh, okay. Okay, so what is that?
The electrons. These are neutrons.
Those are neutrons? What is that?
Electrons.
Really? Okay, put them next to each other. Put them next to each other. Okay, this is a proton. This is an electron.
Make it smaller.
Make
Make it bigger.
Bigger.
How come?
It can't be the same size. Or, yeah.
What size should that be compared to this?
Smaller.
Yeah, because this is 1, and what's that? The size? 1/2000th. So that's way not the same. Okay, so what are these? Those are protons. Let me see your electrons. Are these way smaller than those? Okay. Okay, so if this is a proton, what would that's a neutron? Okay. You need to still compare it to a proton and an electron and see if it's reasonable.
Protons.
Got it. You're helping with protons? Let me see your proton. Let me see a proton. Are you protons or neutrons? Neutrons? Okay, let's see. Do your neutrons look a little bigger than the protons? Yeah? Okay. How about our electrons? Are they pretty tiny compared to the... Okay, then that looks pretty good.
That looks like one.
Awesome. But you only have 2 made. You need to get going. Look at Joe. Okay, sorry. You got 3. Good job. Keep going. Ooh, electrons? Okay. Yeah.
Protons are the yellow and the neutrons are the blue.
Okay. So why are the pink ones a little bit bigger?
Because neutrons are a little.
Okay.
It's so cute and tiny.
They're so cute. Okay, keep going because right now you only have 4 protons. The only atom you can make is beryllium. Because you only have 4 protons. What if I want you to make my favorite element? Do you have enough protons for my favorite element? Okay, how are we doing? What are those? Okay, those are protons. He's asking if those are too big. Are they okay compared to our electrons? Yeah? Okay, so those are what? Those are protons. Those are electrons. Those are neutrons. Now, what can you guys tell me about the mass of a neutron?
Little over 1.
It's a little over 1. So what does that mean when you compare that one to that one? How should it look?
I think that one should be the neutron because that one's bigger.
Okay, so your neutrons now are a little bigger than the pink ones? Okay, so those became protons and those became neutrons. Why did we have to change it?
Because these are bigger than ours.
Because neutrons are bigger than protons. Okay, so that proton next to you looks a little tiny compared to the other one. No, not the smashed one. The one right there. Look at that one compared to those. Yeah, look, put it down.
This one isn't done.
Oh, okay, just checking.
Set up my microphone.
Yes. Okay, looks like you guys have enough to get started.
I'm neutron. Oh, wait. Yeah. How many do I have?
Raise your hand when you think you got your atom ready. You guys got it? So you've got 3, your green is your neutrons? Okay, 3 protons, 3, well, why is this electron not on this energy level?
Because there's 8 on the next energy.
And there can only be 2 on the
Yeah.
Good. Okay, start looking at lithium and figure out what you can tell me about it. Done?
Nope.
Come on. Got it? Good. Oh, your electrons are getting bigger. Okay, you need to tell me. Okay, don't sit on your hands, but don't touch the Play-Doh. Or I'm going to make you sit on your hands. You're welcome. Give me something you can tell me about lithium just by looking at the periodic table. Yes. 3 electrons. Symbol Li. It's a solid. Are you sure?
Yes.
Okay, just checking. 4 neutrons. Malu? It's in family 1. Families are this way. Garrison?
Period 2.
Jace?
It has 2 energy levels.
It has 2 energy levels. Good. How come it had to go to 2 energy levels?
Because there was 3 protons and the first energy level can only hold 2.
Okay, the first energy level can only hold 2 electrons, so we had to go to a second level. We still got more from that one little box?
Yeah.
Really? Yes. Maya?
It's not man-made.
Okay. Oh, pan started going down. Got one?
It's a gas.
I thought we said it's a solid.
Solid. Oh, sorry.
Yeah, it's the one right underneath it. Okay. Damien? Not radioactive, okay.
It's on the left of the zigzag line.
It's on the left of the zigzag line, which makes it a metal. It's not happy. Why is it not happy? Okay, its second energy level, Dagny. Its second energy level is not full. 2 and 5. Okay, you think about that and get back. It is, Li.
If lithium mixes with fluorine, it's going to be...
Ah, fluorine.
that family.
Fluorine family, because the fluorine family needs what?
7. One more.
It needs one more to be complete, right? They need one more to be complete. Good job, Jace. Okay, so that fluorine family, which is what I know you were totally going to see, in that blob of a nucleus, what do you have? 13?
Protons and like 7 neutrons so far.
How many? Oh, okay, what are you trying to get in there? 14 neutrons? Okay.
That's a lot of work for me. I wish I didn't do electrons. Yeah. 14.
14. Okay.
I wish I did electrons.
Okay, I didn't think I needed to tell this class, but I guess I do. Play-Doh is only for protons, neutrons, and electrons. It's not for forming other items, pancakes, flat, whatever that is, snakes, okay? Donuts, protons, neutrons, and electrons. That's it. Okay, now, you guys all got your aluminum made. What do you notice the difference between the nucleus of an aluminum compared to lithium? Okay, lithium was atomic number of 3, and aluminum is 13, right?
Yeah.
And this was what, 27, and this was 7, I think?
Yes.
Okay, what happened? What happens when you compare the nucleus? Dagny.
There's 10 more protons and neutrons and stuff in the nucleus.
Okay, so the nucleus has a lot more protons and neutrons in it. When you look at it, does it look bigger?
Yeah.
Yeah, it's fatter.
It's stacked.
It's stacked. Like my body? Okay. What if I told you to make radon 86? Don't do it, but what if I told you to?
I feel like this high.
Yeah, you would actually need 222 little pieces of Play-Doh trying to shove onto that plate.
Oh.
That would have to be very,
Yeah, really, you're like, no torture, please.
It would be more.
Yeah, you would be tortured because you should have done the electrons, right? That would be a lot of neutrons for you to make. Okay, so as you go up in atomic number, what happens to the nucleus?
It gets big.
The nucleus gets large. If I give you, what happened to your guys' one? Did you destroy it or you didn't finish yet?
Didn't finish it.
Still working on it.
Yeah, because like they started like making a mountain.
Mountains are fine.
Yeah, we
Look, they've got mountains. Oh, theirs is done. Look, they got a mountain over there. It's okay.
stuffed it
It's all right.
in one little
Oh,
like a ball.
okay.
Hill. It was a hill.
Oh, it's a hill. Okay. Not a mountain, but a hill? Okay. So, what I want you to see is that as we get larger and larger on the periodic table, the atomic number, the atomic mass gets bigger, which means your nucleus gets bigger. Okay? If you had to take a radon and compare it to a hydrogen, it would be, hydrogen would be, you done. Done. Right? Radon, you'd be here till tomorrow. Especially if certain people were making particles because they take forever to roll it up. Okay, what can you tell me? Nah, we did aluminum before, didn't we? You guys can tell me everything about. Okay. More neutrons, you can do it.
Oh, actually, I
You had nothing to add on to. Okay, so it doesn't have to be a hill, but it can be like a blob
They
altogether.
were trying to fit it in here until I told them that we could fit it in there. That's
Oh, okay.
purposely. And then that's why it was a mountain.
Okay, so now you get what you can do? Ooh, you're gonna, ooh.
Yeah, but we have 12 right here.
So how many do you need? How many do you need? What are those, protons or neutrons? Are those protons or neutrons? How many protons do you need, Kalani? Why? It's right here. This is potassium. We're doing protons, yes? Okay, so how many protons? How do we find the number of protons?
You have to subtract.
Subtracting gives you the neutrons. How do you find the protons? Hey guys, help out Kalani. How do we find the protons?
You find the protons by looking
You
at
look-
the atomic number.
Okay, where's the atomic number? Okay, so how many protons do we need? Yeah. Okay. I think you're doing neutrons, right? So can you tell Caden how many neutrons he better make sure he has? Okay, you got 20, Caden? No, you're working on it. Okay.
I got mine.
How many electrons do you need?
I need 19.
You need 19? And you put them on already? We waiting for the boys? Typical, right?
That's how it goes.
That's how it rocks.
5 more. What? 5 more? Yeah.
Okay, keep going. And then you might want to start helping them stack the neutrons and stuff in there that they have. Just count them as you go. Did we get it? Ah, I like it. Okay, so what do you have in here?
20 neutrons.
20 neutrons.
Protons.
19 protons. Why did she put 19 protons in there?
Because
that's the atomic number.
That's the atomic number. Okay. Who did the electrons? Well, how many did you put?
19.
Why?
Because electrons.
Okay. Good. Did we get it? Albert actually made enough neutrons without whining, or did he whine the whole time?
Nope.
He whined. You must be getting good at it though, huh? It's a solid. Symbol is K. Dagny. Lori. Not radioactive. Not man-made. 20 neutrons. 4 energy levels. We're repeating already, guys.
Oh, so
It's a metal. I think that's new.
Interruption.
Of course.
Boys and girls basketball games have been canceled this afternoon. Again, boys and girls basketball games canceled this afternoon. Coach Mr. Oyama is asking for girls basketball team to meet him in his room after school today. Again, girls basketball team, please report to Mr. Oyama's after school. Boys basketball practice for 6th, 7th, and 8th graders canceled due to weather. Thank you.
Wait. Maybe there's something else.
No.
Okay, guess not. All right. Go.
It's not happy.
Why?
Oh.